Hi, and welcome to the XFOIL video tutorial. This video will show you how to use the XFOIL program to analyze and evaluate several properties of a given airfoil. The tutorials included are how to plot viscid and inviscid CP versus X plots, how to plot CP vectors along your airfoil, and how to manipulate the paneling on the airfoil. The first tutorial is how to plot the inviscid coefficient of pressure versus the airfoil chord length. Open up the XFOIL program and type NACA6715 into the command prompt and hit enter. Type bend into the command prompt. The window should now display the structural properties of the airfoil. Next, type OPER into the command prompt. You will notice that the text to the left side of the flashing underbar changes from XFOIL to OPER I. Now type Mach 0.2 into the command prompt. This lets XFOIL know at which speed you wish to perform the analysis of the airfoil at. Now type RE 350,000 into the command prompt. This lets XFOIL know at which Reynolds number you wish to perform the analysis of the airfoil at. Now type ALFA 2 into the command prompt. This will set the angle of attack to 2 degrees. Allow the computer some time to compute the results, and a window should display showing you the results of the coefficient of pressure along the x-axis of the airfoil. Type grid into the command prompt to toggle on a grid overlay for the plot. Type CPX into the command prompt to refresh the plot. The plot window will now display the plot with grid overlay. Type CLI 1.5 into the command prompt. This will set the coefficient of lift of the airfoil to 1.5. Notice that the plot window was automatically changed to display the plot corresponding to the new CL. Type CPMN into the command prompt. The minimum inviscid coefficient of pressure and its location on the chord will appear in the command window. Now type CPWR test.txt into the command prompt. This will write a column of chord locations and a corresponding column of CPs to a text file named test.txt. This new file will appear in the folder where the XFOIL program is saved on your computer. Now type ASEQ 0102 into the command prompt. If you're using the Mac version as we are in this video, the program will ask you to type in the numbers 0, 10, and 2 sequentially. The plot window should now display CP versus X data for your chosen sequence of angles of attack. Now type name test into the command prompt. Then type CPX to refresh the plot window. The airfoil name on the plot will change to test. This concludes the video tutorial on how to plot inviscid coefficient of pressure versus chord length. The second tutorial is how to plot the viscid coefficient of pressure versus chord length. Load the NACA6715 airfoil, enter the operations menu, and set the Mach number to 0.2. Now type VISC 300,000 into the command prompt. Follow this by typing CSEQ 1, 1.3, and 0.1 into the command prompt. Again, if you're using this on a Mac, it's going to ask you to type those numbers in sequentially. The computer will now generate data for a sequence of CL starting at 1 and ending at 1.3, moving in increments of 0.1. Now type VELS 0.1.1 into the command prompt. Now type FMOM into the command prompt. This will display the default location of an imaginary flap hinge. To change this location, type FNEW and then FMOM again. Type 0.8 into the command prompt to change it. Now type 999 followed by 1. Now hit enter to return to the XFOIL main menu. Follow this by typing PLOP. Type S8 into the command prompt. Then type F0.0120. Now exit the Plot Options submenu and enter the Operations menu. Now we want to repeat the CL sequence plots we did earlier in the video. Do this by typing CSEQ 1, 1.3, and 0.1 into the command prompt. Again, it is important to remember that if you're using this program on a Mac, the program will require you to input those numbers sequentially. Once the program has performed the required iterations, type BL into the command prompt. The plot should now display information about the boundary layer for a default number of profiles. Now type BLC into the command window. The command prompt will prompt you to select by left-clicking with your cursor a point on the plot in the plot window. Information about this point will be shown in the command window. Multiple points can be selected if desired. The third tutorial is how to plot the coefficient of pressure vectors over the airfoil. At the command prompt window, type in the familiar NACA 6715 airfoil. Then enter the operations menu. Type VISC into the command window and press enter. You are prompted to enter a Reynolds number. Type RE 350,000 and press enter. Type ALFA2 and press enter to bring up the CP versus X plot at that angle of attack. Now type CPV into the command window and press enter. The plot should now show the CP vectors along the airfoil. Type ANO into the command window to bring up the annotations menu. Type C and then select the point on the plot where you want the title of your graph to be. Back in the command window, type CP vectors shown on the airfoil and press enter. A label should appear on your current plot. This concludes the CP vectors shown on the airfoil tutorial. The fourth and final video tutorial here is how to manipulate paneling on your airfoil. Once again, type NACA 6715 into the command prompt. Follow this by typing pane into the command window. Then type PPAR and press enter. After a brief period, a plot should appear showing the panels on the airfoil. Now type N followed by 200 to change the number of panels from 140 nodes to 200 nodes. Now type P followed by 0.25. Press enter twice. You've now changed the paneling bunching parameter from 1 to 0.25. To change the trailing edge leading edge panel density ratio, type T and press enter. Then type 0.314 and press enter twice. The airfoil window should change to reflect your changes. This concludes the fourth and final video tutorial on how to work the XFOIL program.